Alright, I got a new XRD DevNext sandbox. Let's get to work. I'm on my new sandbox and now I need to check a file. So let's go and navigate. First, I need to see what it is. Okay, I have one directory. Let's go there and find what other files I have there. So now if I want to see the contents of a file, I can use another tool like cat and I can see the contents of the file. You know, pretty easy, right? Using CLI tools like ls, cd, and cat. This is pretty good when you have simple projects. But when you are working with more complicated projects, you may want to have some stuff like syntax highlighting, autocomplete, linters, etc., right? And that's when having your IDE with you, with your extensions, makes a lot of sense and is pretty nice. Sounds familiar? Every developer has been here. You finally get access to a machine and then you spend the next hour just getting your tools installed instead of writing code. I'm Jesus Illescas, developer advocate with Cisco DevNet, and today I'm going to show you how you can go from zero to coding in under 5 minutes on any machine. Quick note, before we start, I'm running macOS on my laptop. I'm connected to an Ubuntu VM. Everything I show you today applies to Unix style environments, macOS, Linux, BSD. If you are on Windows, the concepts are the same, but some details will differ. For example, SSH Config path, keychain integration, and how your SSH agent runs. WSL gets you very close to what I'm showing here. Here's the plan. I'm going to show you 2 ways to get productive on any machine in minutes. First, connecting to a remote VM via SSH with your keys, your extensions, and your JIT identity ready to go automatically. Then Devcontainers, where a single JSON file defines your entire environment and anyone in your team can spin it up. If you SSH into remote machines like sandboxes, LAT VMs, cloud instances, this is the foundation. The file I'm about to show you is SSH Config, which is read by OpenSSH, which is the SSH client that comes built into macOS and most Linux distribution. If you are using a different SSH client like PuTTY on Windows, the configuration will look different. But OpenSSH is by far the most common one and what VSCode uses under the hood. Now let me show you my SSH config. Pretty small, right? Let me walk through this. Include just lets you pull extra config files. This is super handy if your SSH setup gets pretty big. You can break things up and keep everything organized instead of having one giant config file. Host. This is the alias you use to connect. It can be an IP or a friendly name. Identity file. Which SSH key to use for this host? I already added my public key to the remote VM's authorized keys file, so it knows to trust my machine. This line is only needed if you are authenticated with SSH keys, and you should be. SSH keys are significantly more secure than passwords. They cannot be brute force, they're not vulnerable to keyloggers, and they remove the temptation to reuse credentials across machines. Now the important parts. Add keys to agent. The first time you use this key, it's automatically added to your SSH agent. Use keychain. On macOS, this stores your keys passphrase in keychain. That means after the first time, you never have to type the passphrase again. No need to manually run SSH agent or SSH add. macOS handles it for you. Linux and Windows have their own equivalents, non-query nor K-wallet on Linux, and the Windows Open SSH agent service on WSL. But the idea is the same. Let the OS manage your passphrases so you don't have to. Forward agent. This is where it gets really useful. I use SSH keys to authenticate with GitHub instead of a username and password. GitHub actually recommends this. It is more secure, there are no credentials to leak or rotate, and it works seamlessly with Git over SSH. This line forwards your SSH agent to the remote machine, so when you're on that VM, you can use your local keys. For example, to push to GitHub without ever copying your private key there. The key stays on your Mac or your machine. You configure this once, from then on, every connection to this host just works. Key loaded, passphrase handled, agent forwarded. To connect to a remote VM from VSCode, you need two extensions, Remote SSH and Remote Explorer. They are both from Microsoft, but they are not present on VSCode out of the box. You can also pick the Remote Development Extension Pack, which has those extensions plus Devcontainer support. To connect to a remote VM on VSCode, let's go to the sidebar, in this case to Remote Explorer. And as you can see here, I have a list of all the hosts that I have defined on my config file. In this case, for the XRD sandbox, you can see I have two options. One option is to connect on the current window, or I can open a new window. In this case, I want to reuse it. Once I click on that icon, VSCode will open an SSH connection to my remote VM. Behind the scenes, VSCode is downloading a VSCode server on my VM. And now you can see on the terminal, I am connected to my XRD sandbox. Here are the list of the files that I have on my sandbox. Here is the server that I commented before. But like I said at the beginning of the video, you want to see the structure of your project, right? That's one of the benefits of using a GUI. So in this case, I can do it by clicking on Open a folder and then pick where I want to start seeing my directory structure. In this case, I'm okay with Home Developer. If I click here, VS Code now opens the file structure directly on the GUI, as you can see. And I don't know if you noticed, but I never entered a username and password. Everything was done through my SSH keys, which is pretty nice. And one advantage that I really like to have my IDE on my VM is that I can use my extensions. So for example, if I go to the extension toolbar and I pick the extensions that are on my VM, I can see right away that I already have some extensions installed. And I didn't install this manually, these were installed automatically. That means that, for example, if I open a file, let's say I open a topology file, in this case for a segment routing, I get the nice coloring, syntax highlighting, and personally I like these colors. They help me to locate better the stuff that I have. And here is the trick that saves me time on every remote connection. So let me first go to my settings, open user settings, and then look for remote SSH. And here you can see an entry, remote SSH default extensions. So this is a list of extensions that will be installed automatically every time I open a remote Explorer SSH connection to my host. This is super nice and saves me a lot of time. Finally, remember the forward agent from our SSH config? Now let's see if it is working. So I am on VSCode, and let's open a terminal. And what I'm going to do is to do ssh-d git at github.com. And let's see. And as you can see, I got a message. You successfully authenticated, but GitHub does not provide shell access. The wonderful thing here is that I never had to put my SSH key on this remote VM. The challenge from VS Code is automatically forwarded from the VM towards my machine, and in machine I do the signing with my SSH key and returning. As you can see, this is amazing for lazy engineers like me who like to work the less I can. This is awesome, so I don't have to handle my SSH keys anymore. The SSH approach is great when you are connecting to existing machines. But what if you want a fully reproducible environment that anyone on your team can speed it up and is the same for everybody? That's Devcontainers. And here's something important. Devcontainers are not a VS Code feature. It's an open specification. JetBrains IDE is supported, GitHub Codespaces use it, and there's a CLI you can use standalone. You add a file called devcontainer.json to your repo. It describes your base image, tools, extensions, settings, and ports. Open the repo in a supporting IDE, and it builds a container and drops you inside. I'll use VS Code for the demo, but the devcontainer.json file itself is portable. Remember, SSH is personal, your config, your extensions. Dev containers are project level. The environment is defined in the repo, shared with the team. Let me show you a real example. This is an NSO repo that we use to build the NSO DevNet sandbox that we have, and we are using the official NSO container. And that's one of the benefits of using dev containers. You develop against the same base image that runs on your staging and production environments. Not the exact same running container, of course, but the same image, same OS, same dependencies, same versions. If it works in your dev container environment, you can have high confidence that it will work in production. In this repo, you can see that we have at the top a dev container directory. Here we have our devcontainer.json file, which defines the whole environment that we are going to build. Now let's go and start the container, and later we can review the JSON file. What I usually do, I press Command P and then more than sign, and then I type dev containers. As you can see, I already have some options, and I'm going to pick the first one, rebuild and reopen in container. As soon as I press that option, VS Code will start a new window that will be open eventually on the container. Now, if I want to see what is happening, I can click here on show log, and this will show me everything that is happening behind the scenes. One advice when you are building dev containers, I recommend that you first build your container manually and later you try with dev containers. I have problems where I have a problem building the container and these logs are huge, so you can get lost pretty easy. The best thing is to build first manually, see everything works, and then you go with dev containers. And now, as you can see, this might take a while, so I'm not going to make you wait. And through the magic of video, we will make this fast. Wow, that was fast. So as you can see, I have VS Code already running. And if I click here to open a new terminal, I am already on my container. If I type, for example, NSO status, I can see NSO is already running. And the nice thing is, if I go to my extensions, I already see I have some extensions installed. and this was done automatically. I didn't have to do anything manual, just start the container, and now it is here. And for example, another tool that I added was Git. So if I type Git version, you can see that Git is already installed on my container automatically, and Git is not part of NSO by default. So this is something that was added on my dev container. So now let's go and take a look at the JSON file. So let's go and close the terminal and let's start reviewing the file. We will not check everything. The best thing to learn about how to use it is to go through the documentation, and there you can find a list of all the features available. But in our case, for example, we have a name, the name of the container. We also have an image, what image we want to use. In this case, this is the official NSO image. Then we have arguments. In my case, I want to pass some environment variables that I already have defined in a file, so I want to reuse them. Then we have the override command, which basically tells Devcontainers don't try to override the default behavior of the image. And this is important because NSO runs a script, so I want that script to be run. Then the container user, in this case NSO, which is also important, is quite a detail that you have to keep in mind for NSO. And then, for example, which ports I want to forward. After that, I have the features, and here you can see that this is how I install Git. There are already some features available for Devcontainers. The best thing to do is to go through that URL and see all the features that are already built. So in this way you can reuse them. Then we have something interesting, customizations. Here, for example, this is the place where I can define the extensions that I want to build. And as you can see, I have some already put here. Then I can also define settings. And in my settings, I can configure how I want the extensions to behave. This is quite handy because I can define, for example, how piling should be configured, or for example, how Git should behave. And in the case of the NSO extension, what configuration should be. This is quite nice when you are thinking that this is part of your repository. So any member of your team can just do git pull, get git clone, for example, get the repository on the machine, and basically start the container, and they will have all the environment ready for them to work. And before we end, one last thing I want to show you. Let's open a new terminal and let's do SSH. What do you think it will happen? Let's see. So as we can see, we were also authenticated. So this is super nice. My SSH key were also forwarded, well, not forwarded, the agent was forwarded to my container, and now I can start working right away here without ever having to pass my keys to my container. And remember, this was done automatically. I didn't have to do anything manual on this part. If you work on existing VMs or sandboxes, remote SSH with default extensions and agent forwarding gives you a consistent personal environment on any machine you connect to. On the other hand, if you want a fully reproducible environment that lives on the repo, Devcontainers are the way to go. Clone, reopen in a container and start coding. No setup conversations, no works only on my machine. I've linked everything in the description, the SSH config snippets and the Devcontainer JSON example from today. Start small, set up your SSH config this week, or drop a devcontainer.json into a project. And if you do, leave a comment. I love to hear how it went. If you enjoyed this video, please hit the like button, subscribe to the Cisco DevNet channel for more content like this, and leave a comment below with any questions you have. Thank you so much for watching.